So we've already done balancing chemical equations.
Yeah.
So you guys should be very confident in that. You guys know the difference between the reactant and the product, right?
Yes. Yeah.
I would hope so.
Yes, I would hope so too, right? So you know that the plus means that it's this and that, right?
Yeah.
The arrow means
No.
the arrow.
How we do it that way?
The arrow means what?
Oh, it's either.
Direction.
No, the arrow there would mean what?
Oh. Make sure it's the reaction afterwards.
What is that? What is the reaction afterwards called?
Mathematically speaking, it's the equals.
Product. Product.
It is the product, yes. Yes, but we will never use an equal sign.
I prefer the equal sign. But
No,
would
I
prefer
don't
it
care
as
what
the
you
equal sign.
prefer, but.
I remember.
By the way,
the
we're
equal
gonna
sign.
learn.
Hey, what is the coefficient?
Coefficient is a number in front of it.
In front of what?
What is it, the chemical equation? The compound?
The compound, there you go. Compounds are an element, yes. Okay, you guys already know how to balance the chemical equation, right?
And we have
Yeah.
a free throw.
Oh, you guys aren't getting a brief overview. You should know this at that point. We're skipping it. It's done, it's done, we're behind. What's that?
Why is this on chapter 4?
Because they're a little behind my schedule. My schedule I give to you guys early because I think you guys should know. That should be the first thing that you should learn in this class, how to balance a chemical equation. Because you keep seeing chemical equations and you don't know how you get to that point. So I teach you guys a little bit different.
I mean, like on the book.
Yeah, that's the reason why it's in chapter 4, because if they teach you one way and I teach you another. It's called academic freedom. I have a freedom to give you guys pain that first week. It also lets people know what they're getting themselves into, right? First week, you knew exactly what you're getting yourselves into, right?
Yeah.
Yeah. I didn't fake the fun. So these are some of the things that we don't talk about, or we haven't talked about in a lot of detail. Okay, we know that the G, that subscript, it'll be a subscript, in parentheses, G stands for gas. Subscript L stands for liquid. Subscript S stands for solid, and AQ stands for aqueous. We know what aqueous means? No. Well, it does mean that if it has hydrogen in AQ, it does mean that it's an acid. But the term AQ doesn't mean that it's an acid. It actually means that it's in water. It's dissolved in water. So how acids are made, they take gases and they bubble them into water. Or they'll take a solid, and they'll bubble it into water, right? Was it there? Wow. Of course he's there today, right? I need to get that one fixed too. So he's probably trying to fix my problem there.
You're gonna tell him to call.
Okay. Sounds good. You gave him the number?
Brenda said she had it.
Okay. Yeah, probably because they've called several times. Yes.
So if acids are aqueous and aqueous means it's dissolved in water, what happens if you completely dry out an acid?
Then it's called anhydrous, right? And it will no longer, well, depending on the product that you're working with, it will no longer be an acid. It goes back to acting like it's covalently bond. Typically, when it is dried out, it's not dried out completely. So if it's not dried out completely, then it's still an acid. And so typically, like when you guys see, so I'm trying to give you an example. Citric acid. Citric acid is a nice example. So it says citric acid, and then it'll say hydrate or hydrate. Basically means that there's water present to help it keep its acid form. Okay, although citric acid isn't typically bubbled in, it's a powerful nature. Okay, how you guys feeling about that? You guys understand? Okay, so when we're writing a chemical equation, to be thorough, we need to start putting those subscripts to let me know whether it's a solid, liquid, gas, or aqueous. This becomes important when we start analyzing what's going to happen with this chemical reaction, when we start talking about kinetics. How fast is this going to happen? So let me give you an example. If something is solid and I put it as a block, let's say I have a block of iron, right? Big old block of iron. Now, and I stick it in an acid. That big old block of iron, that stuck in the acid, is it going to react evenly throughout that whole big old block of iron? Or is it just going to be on the surface of the iron? It's going to be on the surface, right? So is that gonna slow my reaction rate? Rather than if I had iron powder and I shuffle iron powder in there, my reaction rate gonna be a little bit slower.
Yeah.
Yeah. Because it's only able to come in contact with the surface. So that's gonna slow my kinetics. So we need to know those things so we have an idea of what's gonna be happening with the reaction. So that's why it's important that we include that in there. And I'll show you guys an example here in a minute. Okay? Questions? Concerns? Good. It seems like a Monday. You guys are kind
You
of.
forgot about cash.
I forgot your cash. Oh, I have cash.
No, you forgot to say, ask for
Okay,
cash.
don't worry, I will. I made some last on Monday. We took a couple of bets. I think I made a $5, you know. Had a couple of bets, they lost, you know. They were like, yeah, I want to bet, I want to bet. I'm like, okay, let's go. Put your money on the table. So other symbols. There are other symbols that you guys will run across. One of those is the delta. Delta basically means that we're adding heat or we're making a change. So delta typically means heat associated with it. So if you have delta across that arrow, we're adding heat. Okay. Delta is a Greek symbol. That's the capital delta. The lowercase delta looks like a funny looking beat. Okay. Okay, so the next thing that we're going to talk about is ionic reactions, right? So I told you that you have to tell me what it is because it's going to start becoming important. Okay, this is one of those cases where it becomes important. We're going to kind of deviate from the lecture notes. I'm going to teach you guys some things so you guys will have a good understanding, and then see what you guys think. So, but we're going to talk about these aqueous solutions. So if we think about salt, have you guys played with salt?
Yes.
What happens when you put salt in water? It dissolves. Okay. So what do you mean by it dissolves? It mixes in the water. So let's be very specific about it. When it dissolves, it actually breaks down into its ionic components. We know that salt, sodium chloride, is an ionic compound, right? Because it has that plus charge and that minus charge, and they came together and sit there and make it salt, right? Soon as we put it in water, water acts like a home wrecker. Water will actually go in between the two and split them up. Okay, you guys know what a home wrecker is, right? Yes. Anyway, so you've got a lot to learn. We got to work on you a lot. Hello, how are you?
We're gonna try to fix your audio.
Thank you.
Right.
So try.
I heard try.
Yes. Box. It says you have to get in the box.
Yeah.
You guys got the key to the box?
Yes.
Okay, good. Thank you. So anyway, water goes in between and it splits them apart. So you will have your plus charge and your minus charge. And so your plus charge and your minus charge will be sitting in solution. Your sodium plus and your chloride minus will be sitting in solution. I'm going to draw that on the board. Let's see. So normally salt is a solid, right? NaCl, right? So as soon as we put in water, what happens is
Hey Jonathan, this was good. So where in the classroom?
it becomes and it dissolves.
Yes.
Now, what's happening at the molecular level is
Okay.
shut down in the middle of the lecture.
Okay.
So,
Like, he said that they had no audio let it shut down. Yes, one more time.
so
To try on the top.
this is what? It's water. Okay, water is a polar molecule, meaning that it sets up poles. It's a covalently bonded molecule. They're sharing electrons, but the way that they're sharing is
I'm
uneven.
sorry, you put off.
We kind of talked about that. I told you about my sisters. You taking the video game most of the time and I'm getting it part of the time. We talked about that? Okay. Good. So this guy, the lowercase delta, this guy is partially negative. So lowercase delta basically means that it's partial, meaning that you're spending more, the electron is spending more time around the oxygen than it's spinning around the hydrogen. So it has more of a negative charge associated. Not a complete negative charge because it's going back and forth, but it's spending more time around the oxygen.
Can you turn on the desktop? What happened?
Want me to send him the link? So he can.
Oh, he's driving.
Oh.
Jonathan.
But the last time he had says here. Do me a favor, talk back there.
Hello.
Now say it again. Okay, it's working. Okay, I think we're good. Thank you. Whatever you guys did, you did something. Yeah, it seems to be working, because at first it wasn't. What did you guys do?
Set it in.
Okay, perfect. Thank you.
Are you sure it's working?
Okay.
Yeah, that's the stuff. And then if we had somebody on the other side. Thank you.
They have speakers. The what? Like, come on. I'm pretty sure it's expensive. Like, it's a little microphone, like,
That's how I was thinking that it's free.
but they can't afford sprinklers.
Okay, so these guys are partially negative, and then the hydrogens are going to be partially positive. Okay, so again, the electrons are being shared between the two, right? So where are you? Okay, these are the electrons that we're sharing, right? Okay, here. Give it back. Here. Give it back. Are we sharing?
A little bit.
No, we are sharing. He gets it, doesn't he?
Yeah.
That's sharing. By the definition, what is the definition of sharing?
You give them an item and get it back.
And I get it back, right? So we're sharing, right? So give it back. So in that case, we're sharing, but are we sharing evenly? No, we're not. So that's exactly what's happening. Oxygen is getting the electrons the majority of the time, right? Hydrogen is only getting it a little bit of the time. It's sharing. So that means that oxygen seems to be like it's more negatively charged than hydrogen. Okay. Now, because of that, they orient themselves around items that are charged, right? So they get between sodium, say, sodium, don't need chlorine, got me, baby, right? And then Soon as sodium turns its back, they go to chlorine. Chlorine, you don't need sodium, you got me, baby, right? And they surround them. So they keep them separated. So that's what happens when things dissolve. In water. Water is one of the best solvents because it's polar. It's able to sit there and separate them. So when we're talking about those aqueous solutions, we're talking about them being dissociated, right? I'm gonna spell that for you, dissociated. I'll probably misspell it, but we'll put it on the board just so you guys can see it. Okay, so they're responsible for dissociation. They're also what we call it ionization. They form ions, right? Because when they're together, what charge do they have? When sodium and chloride are together, it's neutral, right? It has a total of a 0 charge. That's what makes them an ionic bond. They balance each other out, right? But as soon as you put the water in there, you've got them separated. Okay? Does that make sense? So let's put this equation that we have on the board. So this here is called the molecular equation, or it's also called conventional. I've done it. You're just tired or something. Chemistry is boring.
It's been interesting. So we're going to the more difficult. Yeah.
How easy.
We're just prepping up for it.
Okay. So okay, so we have the conventional equation. The first thing that you always want to do is make sure that it's balanced. Is it balanced? What do you mean by no? Wait. I don't know. I'm asking you. What do you mean by no? If it's no, then what do I need to do to fix it? What was that? Add coefficients?
We're missing an additional.
We have calcium, one on each side, right? We have chlorine, there's 2 here. We have 2 chlorines here,
Oh.
2 on each side. We have 2 silvers, 2 on each side. We have 2 nitrates, 2 nitrates, 2 on each side, right? So we know that it's balanced. Okay? So we always want to make sure. First thing that we want to do, check to make sure that it's balanced. Okay? Now that we know that it's balanced, I'm going to show you what really happens. Okay? So this is going to be called the total ionic equation. So we know that if things are aqueous, they're gonna be dissolved. Okay, because as AQ, they're gonna go through dissolve. So if we dissolve this, we're gonna have calcium. What is calcium's charge? Plus 2.
Oh, there you go.
Plus 2. Chlorine. What is chlorine's charge? -1?
Yeah.
Okay, and there's 2 of them. Let me explain this to you. I need to borrow 2 people. 2 volunteers? You 2 guys. Come on,
How'd
come
you know?
on. Okay, so I am calcium. I'm calcium. I'm playing the role of calcium today. This is chlorine number 1. This is chlorine number 2. Give me your hands. All right. Okay, so who's connected to the chlorines?
Calcium.
Calcium. Soon as calcium lets go, what happens?
We're gone.
They're separated, right?
Yeah.
They're not connected to anybody.
Damn.
So they're only being held together by the charges. So because of that, there's 2 independent chlorine ions, right? So we put a coefficient instead of a subscript. So it goes from a subscript to a coefficient because they're no longer connected. Does that make sense? Yes. Yes. Okay. So the same thing is going to happen here with silver nitrate. So we're going to get 2 Ag plus aqueous plus 2 and 3 minus aqueous. You guys know that this is the polyatomic ion. It's going to act as a whole ion. It's going to stay together. Okay. And then on the other side, calcium, since this is aqueous, it's going to split out from the nitrate. And then, since this is a solid, if it's a solid, a liquid, or a gas, if it's a solid, liquid, or a gas, it will not split up. Okay? How many of you guys have gone to parties before? Okay, some of you guys aren't raising your hand. I know you're lying. Because I saw you there the other night, so don't lie. Okay, so most of us have gone to parties before. Now, when we go to parties, there are a couple of types of people. Well, there's two major types of people. You have the doers and the watchers, or what we call the spectators, right? The doers are the ones that are going around, hey, oh, let's dance, and doing all the stuff. Those are the doers, right? And you have the spectators, the ones that sit on the wall and watch everybody else have fun, right? So, which one are you guys? Are you a doer?
Yeah.
Are you a doer or a spectator? You're a spectator? Doer? Doer? Spectator? You guys over here, what are you guys? Doers or spectators? Doer?
Spectator.
Spectator? Spectator?
Yeah.
Are you a doer? You're both? It depends on the party, right? Okay. You're a spectator? Okay, so now, the thing about spectators, all they're doing is watching, right? Or sometimes what spectators do is they bring the cool people to the party. I need to go to the party, man. I don't want to go by myself, right? And then all they do is sit there and sit on the wall. And then the other guy goes off, hey girl, what's your name? Can I get your number? Hey, let's go home together, right? So that's what's happening here. We have doers and spectators. So if it's exactly the same on both sides, it's a spectator. So for instance, we have the nitrate. Nitrate is exactly the same on both sides. We have our calcium ion. Is exactly the same on both sides. So these guys, they're not really doing anything for the equations because spectators, nobody remembered that they were there, right? Was at that party? Oh, he was there? No, because he was standing on the wall. You never paid any attention to him because he was spectating, right? So they get canceled out of what we call our net ionic equation. Okay. So the ones that are really doing the work, that are hooking up, that are making things happen, is going to be the ones that are left over. Okay. So that's going to be our silver and our chloride ions. Okay. And they're going to make together silver chloride. The other ones were just there to bring them to the party. Okay. Questions? Okay, you see how this works? Can you handle it? You guys handled the truth. You guys want to give a test run? See if you got this? Okay, so what I want you guys to do, I want you to give me, I will write down the chemical names. I want you to give me the chemical reactions, the conventional chemical reaction. Then I want you to give me the total ionic equation and then the net ionic equation. Be able to identify the spectators. Okay? You guys ready? Okay, so here's your reaction.
That's the other piece of paper.
So anytime that you see solution, you can assume that it's aqueous unless they tell you otherwise. Okay. Okay. See how well you guys are with that nomenclature, right? And a precipitant basically means a solid. Okay. A precipitant means a solid. It's too loud, but it should not, gosh. It does, actually. And then you should also be able to. Okay, okay. You're like my family, huh?
Yeah.
Real loud, okay.
You go. All right, so what are you guys getting?
Oh, all thing I know is that ammonium sulfate tends to bond things together, but that's it.
That's where you're down. Today. I can find out. Mr. Teacher Assistant.
I think.
Relax. What do you points is the test worth? 100?
Or do you mean percentage wise?
I guess.
It's like,
So it's cute.
Percentage wise?
I guess so, yeah.
it's just
35,
Friday.
40. I think he dropped it to you guys. I don't know. Share it's a little bit of this. You updated it.
What was this question?
It's 35, 40.
What was my question? I asked them how many points the exam was.
Oh,
He said 100. He said overall percentage 35 or 40.
just that one single exam.
I don't know.
It's just like you said, like 10%.
I'm assuming like all exams, but just
Okay,
that one
makes
exam, you know.
sense, yeah. Yeah, that makes sense.
Sulfur also. Or do you just not include what? Yeah.
Yeah.
Yeah, what was that?
Experiments technically, the engineers was already. Oh, what?
What's the normal state? You could have the normal state of ammonium sulfate. Did you see that? That's what it goes based off of that.
Any sport? Could be.
Why is there a lamp down here? Yeah, but there's a lamp.
I see. So it just as a fancy.
Wait.
Oh.
How? See. As mentioned, I'm probably bullshit. I have to learn at least something.
No, it should be a full, right?
I feel like Scotty's the same.
Right.
I feel like you're the same.
It's all fake, right?
You're just trying to get a pass. Like at the end of the day, I think I'm gonna get like a very, very low B
So funny.
at best.
Which one?
Like I'm understanding it now. But that wasn't the case for fucking conversion. It pisses me off. Now I understand it a little bit. But that's because he had.
Put it right here.
What the?
I want it.
Can you plug it in?
I need light.
Nah, bro. Check my word. It has rewiring, so it needs a ground.
Just stick a screwdriver on.
That shit. I just-
Stick it on the ground. What, can I break it?
No.
Well, man.
No, I don't see myself not
You know, satisfying.
I'll bring those.
satisfied.
You don't see like glass like satisfying.
No, I'm fucking mortified.
Like, okay, obviously, like if I'm handling it, but
I did that.
no, obviously, I
different,
get
but if you
scared.
watch it.
Yeah, but if you watch it, like,
See, watching it,
but like if you're actually doing it to actually break it, like, not on accident, actually do it on purpose.
purposely, no, I've never done it.
It's so fun, like you just like.
What I get? So
Right on the board, so you go see.
I got you, bro. Say I won't. He'll walk back in and be like, what the?
It's a pigeon.
It's fucking wrong. Well, right.
Well, that's, yeah, that's good.
It's NH or something? It's what is it? Ammonium sulfate? Is that a solid? Is that a gas?
You said it's a solid.
Is ammonium sulfate a solid?
Yes.
Appreciate it.
What are, what's that?
Why you didn't trust me? You're like.
I mean, you know what I'm saying? You don't even try it. I don't know.
I know where it's at. Allow that to be.
See, I wasn't processing.
Yeah.
And they use
I
it
said it
also.
So, do we both eat this?
So you.
I think you broke his, I think you guys should help us out.
What?
Yeah, that makes sense.
So what is that? That's the charger?
Yeah, that's the charge.
We're supposed to also work on the ionic equation, right? Not just the basic equation.
You need to do the conventional equation, total ion.
Yeah, and that's
I'm still trying to find out the difference.
So
How's it going?
molecular equation is the atomic
So
equation.
they kind of want me to go up there and put it myself, and like, I'm not sure how I feel about that.
Go ahead.
And he said he was right, so.
I did not say that.
Molecular
It's gotta-
equation, classic, it's
Show
just
us.
classic.
I'll show you the wrong way.
The,
Dr. Henry?
Alright.
the total ionic equation, you just break it
So
up
we
into
we
different ions.
did ask
so like
Mauricio for a little bit of help on
lead
ammonium
ion,
sulfate.
The
What would that
nitrate
be?
ion,
Mhm.
you just break it down into
States it'd
separate
be a
ions.
solid, a solid.
And then the net ionic.
It's
equation,
aqueous.
Thank you. Ammonium sulfate?
You,
Anything that's with ammonium
you basically
is
cross out
always going to be aqueous.
the
We'll be talking.
ions that are.
Yeah, because like the first one you put is a.
or like the ones
Actually,
that-
we've already talked about it. Yeah, I'm pretty sure we did.
Like the ions that don't
Oh,
result
yeah,
in
thank
the.
Yeah.
We talked about solubility.
Not
Do you guys remember us talking about, I think it's chapter 2.
I don't remember, to be honest.
Look in chapter 2. Towards the end of chapter.
But I know how to do the math.
Nomenclature.
Okay.
I'm not quite 5% sure. Okay, maybe it wasn't this chapter. Maybe it was chapter 3.
It stays NO3.
That's the very. We did.
But I did have one. Except for the arrow. No, it would be.
No?
Ammonium sulfate solid.
What was that?
Ammonium sulfate solid.
Ammonium sulfate is gonna be in a solution. It's gonna be aqueous, my bad. I need to put solution up there, but.
What's the current?
It's this one. We'll be going over it the next. Next.
Ammonium sulfate is a solution.
It's gonna be a solution. I should have put aqueous. I should have put solution. My bad.
What's happening? So you have to figure out.
Oh, you just do exactly what I just did.
Oh, that's not true.
Say, but darn it, Dr. Henry. Yeah, I'm working on getting this one. You two don't smile at all.
That's the, like, how you put PV, right? Yes.
Were you able to get it back?
They are locked up right now. We have to wait for the secretary that has the key to them. So she's at lunch. She'll be back about 2:30. So she's there. Yeah, they're gonna handle it.
I have a quick question. The lamp.
We use it for, well, we don't use it, but it used to be used for chemical experiments to show electricity. Yeah, exactly. Now we use these LEDs, right? We've got fans.
Oh, I know.
I know what I want to do with it, but other people want to use it, so. Chances are,
They're under,
why not?
like you're behind everything.
Yeah. Yeah, LEDs are much more efficient because they're small.
Yeah.
Just what you want to do.
For right now, it will belong in the physics room, so that we do use it. And I'll ask if she wants it, she doesn't, then we'll dispose of it, because like I said. we can always use that, so.
So just keep that down.
We can leave it there for now, although it's a cute little lamp.
There used to be a fan once.
The high efficiency bulb. I thought you were gonna put it up there. What's wrong? You back it down?
Well, I don't think it was a majority vote or anything.
Well, you can start. It's okay. Go ahead.
But like, people are gonna laugh at it.
That's all right. Won't be the first time. Won't be the last.
Half-hearted.
It is comforting, right? Okay, well, you need to develop a thick skin, right? You should always have a thick skin, because there are gonna be people that are gonna be out to get you regardless of what you do, whether it's right or wrong. They're gonna try to do their best to knock you off your game.
Skin is limited to Rex paper.
I'm wrong.
It's like limited. to-
I will not be down.
It's not.
I will not be.
You have
She
not
said she
been
will
down.
not be down. But she's trying to do you a favor. She's trying to make you strong, thinking that skin.
I see.
You have knocked me down.
I know.
Right?
Yeah.
Because when I tried to send you only the highest score.
There's a lot
They're
of
like, I
tests,
got feedback somehow.
and but I think they're from microbiome.
99.9%. They are.
It is.
Half the shit.
Okay.
Oh, that's in the dishwasher?
Yeah.
Yeah, no, we put those in there because they were for microbiome. They were all of these things that have been thrown in them, and left in them.
You're wrong. I
Liquid
probably-
dissolved and everything like that. So, why they
But I
not
can
clean them?
balance it out.
So chances are we should probably get a scrub brush and scrub them.
Yeah.
If we can. If we can't get them.
Ammonium sulfate.
Here's what you want human arms with. Make it do it.
All of a sudden, you trip and they all go.
That sulfate might.
So, yeah.
Like,
Go
I
Tico.
went through, I had nothing said except for maybe like
Confirming with.
an owl-inspired bird head and like a frill of that.
No, no, I had worse.
Because like right now, I'm leaning towards a tilted-shaped body, covered in ears and feathers, with a barn owl skull.
Okay, yeah.
Like iridescent feathers that like frill out for show. Probably.
Show me that they're iridescent.
No, the problem is drawing this book.
This is my school.
I'm already like used to owls. But barn owl specifically, it just looks pretty good. The funniest thing is owls are stupid. Like, their dome is super wide, they're dumb. It's that dichotomy. I am the negotiator, I know how to sweet talk that. Also, a lot of people care about me.
And then what is that?
That's crazy.
Yeah.
I just didn't have the dignity.
Already is so good.
I always had that.
I used to try and go with it. But it's not true.
Well, no one has said you're wrong yet, so it looks like you're right.
I hope so.
I haven't looked at it yet.
Ah.
No, right.
Oh, I can see now. It's really small. I know what's coming.
Okay, so who's gonna do the total ionic equation?
Is that correct? Oh.
See, I knew you were right.
Who's gonna do the total ionic equation?
come on, no, acetic acid.
No. Not what, not at 17.5.
That's just fine.
And then. Volunteers? Volunteers?
I can go again.
No, I don't want you to go again. Gotta pass the baton. You did the heavy lifting, right?
I hope so. But can I rewrite that for? Because I really can't see it.
Yes, you can. Which four?
Um,
Doctor, this is not a equation that you wrote, what form is that? Like, what
That would be the conventional.
convention?
Yeah.
So,
Conventional is one that we typically write, but when you get into real estate and into chemistry, that's what it's.
So the conventional is not balanced yet?
No, it is
Oh,
balanced.
it is balanced? It's all balanced.
it's over there. Yeah, they're all of them are over there.
Oh, maybe. In specific color?
There's a lot of
Use the color that they see.
What are you saying? I think colors that you guys can't see.
them. I mean, the green I can barely see from here.
Oh, no, I picked up green.
There's a real total up here already. Oh, Jesus Christ, you cannot see that. Reina, can you switch markers? That looks like shit. That looks like shit. Can you switch markers, please?
Oh, it's hard to see. Fine, it's trouble seeing on the side. We've done it before and it didn't work well. To use the color, this purple.
Just like any other color than that one.
They complain about the green.
What's your favorite color? You said. Yeah. it's okay, well.
I just want to be able to see it. Is that the black one that works for me?
Oh, yeah, it's the black one.
That's like add plus or like charge plus?
Just call me.
Good job. I know. That's what I was getting so much to do it too. And then I saw over here, couldn't see the 4.
Can't see the 4?
I couldn't, that's why I went up to change it.
Oh.
Oh, mine does look smaller as soon as it gets like further and further away. You're fine.
I remember when we see
I was like, oh.
Oh. Wait, Brandon? I think you're supposed to separate lead sulfate also.
the GCL and solid example, right?
Did he? I think that would imply the last one, not the one, not lead sulfate.
It's so like.
Because I don't think lead sulfate is a solid. Because on mine I put the last
Precipitate.
yeah, precipitate because
That's a solid. Yeah, that makes the lead sulfate a solid.
I'll just wait until we see. We'll wait.
Precipitate lead sulfate and ammonium nitrate sulfate solution.
Also, I got it back.
I'm assuming that the solid does not get separated from the liquid.
It
I'm
does.
not sure. It doesn't.
I don't think so.
Because I was busy typing up on those questions.
That's great.
We'll see. We'll see.
Oh, yeah. But it's a solution. I thought he's like.
Jake, man.
Okay, so.
So it would be. Yeah. Pretty much. Does it repeat? It stays.
So it doesn't change.
Hey. Oh. Are you gonna put up the next answer?
wondering about that. No one said anything, so okay. Yeah. 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 You are. Don't play your smart.
And then SO4 negative 2. And that's it?
Yeah.
So you have two dots. No. Oh, no. That's one of the arrows. I'm sorry. No, I was thinking myself.
You said PV plus 2, right? Now, see, I'm
So then it
Anyway, to copy on card, but, so now we're going to ask, PV plus 2, and then so 40 brought that down, right? And then you also brought the flame.
Yeah.
Yeah, yes, ma'am. Yeah, I trust you. I trust you. You can do it. Go on.
How's it going?
Pretty.
Do you remember this? Remember this from, then it would also drop down. So it's a solid liquid, but gas. It will always stay gas. Okay, only time it separates is at first.
For this, yeah. Yeah.
Whether it's gonna be able to separate or not, talk about that here. in a minute. Me and Victor were talking about that. Like, did I talk to you guys about it already? He's like, no, no. I'm like, yes, I did. And he's like, no, you didn't. I'm like, I haven't yet. It's coming up. Yes, if it's always going to be a risk association. Liquid, I would say. Only get a. Okay, you guys ready? You got some answers?
Yes.
Looks good. Do you guys all agree with this? You do? Good. Perfect. Pretty freaking now.
Didn't take this over there, but. Kind of wobbly.
No, you can see it. Let's see.
Yeah. That's. Let's see where. That's the platform.
I have 15
You almost take
minutes.
you made it so it could be-
Okay, so now you guys are feeling comfortable with. I know,
Not that comfortable.
not that comfortable. You guys want to do one more?
Yeah. Wait, were we right?
Yes, you guys were right.
Oh, sweet.
Okay, so I'll do one more on the board. We'll move forward. Sure. So, first off, when you're given the chemical name, you've got to pay attention to all of the things that you guys have learned, right? So we've done nomenclature, you guys should be pretty comfortable with nomenclature at this point, right? So, lead to nitrate. Lead has a +2 charge. Nitrate, we know, has a -1 charge. So we need 2 of those. Okay, it's a solution. So solution, anytime you see solution, it means that it's aqueous, unless they say that it isn't. Very rare that we'll use another solution for solubility, not for this class. Later on. Okay, so the next part says reacts with ammonium sulfate. Ammonium sulfate, and I put solution at the end. Now, ammonium sulfate, if it was a solid, it also will separate, right, once it's in solution. So then you'd also assume that it's going to separate naturally too. And I'll show you that here in a second, right? Also, it deals with solubility. Okay, so here again, aqueous. Ammonium is a +1 charge, sulfate is a -2. So we need 2 ammoniums to balance it out. Right? So on the other side, it says that we have lead to sulfate. Well, lead 2, we know that sulfate is a -2, so they balance each other out perfectly. And then we have ammonium nitrate. Well, ammonium is a +1, nitrate is a -1, they balance each other out perfectly. So then the next thing is, now that you have the chemical formulas correct, is to balance out the chemical equations. Right? So we have 2 of these, right? 2 of these. So when these guys make that perfect solution, you have to have a coefficient of 2 in front. Okay? Okay, so the next part is, because these are aqueous, they're going to dissociate, right? So when they dissociate, you get your lead. You have 2 nitrates, right? Because again, remember, lead is the one that's holding them together. So just let that go, they're on their own. So there's 2 independent nitrates. Here, ammonium and sulfate. Sulfate is holding these guys together. So this sulfate lets go, you have 2 independent ammoniums. And then of course we have our sulfate. Again, all aqueous. So then the next part is lead sulfate was the precipitant. We also know that that's a solid. So we're just going to drop it down the way it is. We're not going to change it. So if it's a solid, liquid, or gas, it cannot be separated. It stays together. Okay? Solid, liquid, or gas, it stays together. Okay? We have the ammonium nitrate, which is aqueous. It can dissociate. Okay? So then we get rid of the spectators. We have ammonia and nitrate and ammonia on both sides that are exactly the same. So they're just going to cancel each other out, kind of like in math. You guys remember if you have an x on this side of the equation, you have an x on that side of the equation, right? You cancel each other out. Same way, right? Like fractional increase. Okay, so then the ones that are really doing the work of this reaction are the lead to and the sulfate. They come together to form lead to sulfate. That's it. Does that make sense? Okay.
Yes, it makes sense.
Makes sense. Sorry, next time I'll put it on the board again. Oh, I have to put it on the board again anyway, so. This class here, this class, matter of fact, I've dropped at least 2 pounds each month just from the walking back and forth to the damn desk. And the only thing is that it's not coming off my gut, it's coming off my butt. So my pants keep coming down, and I'm like, you know. Okay, so let's do another. So I want you guys to give me conventional equation, total ionic equation, and the net ionic. Give you guys a few minutes. Oh, sorry, it's not showing, sorry. Let's do it. I'll put it over here. One in Fireball, camera catches the entire board, and then on the outside. I have all these other rooms that I can't use, you know. And then this one is just like. Manganese 4 nitrate. I need to get a block. Full block. Now. Actually, no. Let's. Yeah, so that's manganese 4 nitrate solution.
got some, well, I got that. So I haven't written up the product yet, but I'm still figuring out some charges. But
Yeah.
right now, I'm just doing. That's what I'm trying to get. Yeah. Oh. Oh, I tried. See that, I just wrong. Hey, so I had a question. The sodium
Yeah.
for hydroxide. Hydroxide. And,
Yeah.
See,
yeah, they're.
I think you'd be
Alright,
better
I'll
off
sign.
writing it first. Writing it individually first, and then from there. See, yeah, that was all yeah, except for this part right here. You don't put the charge just yet. I don't think you put the charge in general when you're making the first conventional.
Right, so you don't put the charge in the original?
Oh, I did.
Unless you're doing the total one. You have to do it anyway.
I see.
Yeah.
Okay. No, I just wrote it down.
Okay, so if you look at it, this has one, right?
Okay, then I'll take a volunteer, right on the board, can you answer? I'll be right back.
What did you pick this for?
Yeah.
Oh, I just put my phone.
Why not? ¿Por qué no?
Hold it, nice. Oh, so I got. Almost best arrows. I got that. 6. Yeah. I'll try to understand what you did. Yeah, it does. It bothers me. Yes. I see you going out in the mission. Right, yeah. So you just go into the restaurant. Yeah, well, it's a college course. You pay in college, yeah, you paid, so you can do it. Yeah. Well, nice, exactly. There's limitations. Yeah, there's no limitations, but at least you can do that. You can't just come in here and kill you. Right. It's like, that is an example. Yeah. I mean, not this class, not this class. In other classes, you can eat, drink, eat, really. Oh, I had professors who didn't eat at home. Yeah. I had professors who didn't. Uh, 6 times.
You just went the whole thing.
That's only the 2 points. Two.
I know it doesn't break. It's like just jumping. Yeah. Because I don't want to work.
That's what I did. Also, I didn't say it. Oh, I read work right now. See, I didn't get that, so I know I get.
So this one's a +4 charge. Right?
Yeah.
So when it moves over here, this one's has to go forwards.
But, yeah.
Now because you change this number, you also have to change the follow power.
Yeah. It's basically your back.
Because also yes, sir.
Well, see, now I guess I guess myself, but I got the note instead of right, just gonna get the numbers right. That's it. That's what I want. We didn't finish it? Line. Cat. I call cat.
Yeah.
Swear we finished it. No, I remember that, but yeah, no, I swear.
Did you guys remind that?
I think it was like.
Did everyone finish lab 9 or the previous lab?
No.
I already threw away the paper.
No, it was the one with the fire, right?
Huh?
Yeah, the crucible.
Bro, ours wasn't working for shit. We're not even anywhere near done.
What about that? You guys have anything? You needed to heat it up again. Janice, did you guys finish the previous stuff?
No, last night, no one did.
You guys gonna tell them?
Oh, wait, what do you mean? You left?
Like you go get the lab 10?
We have a lab 10 already.
No, but.
No, the materials.
Go like the materials to it today.
We're gonna do both.
Yeah.
We're gonna do both.
Turn it in the group.
Cause all we got, we're almost done, like we're at the end part, like.
Have you guys put water in it?
Yeah, we just have to like, do the calculations.
You guys are some.
We still forgot the water.
We still need a mower.
Yeah.
Well, he said he was gonna give us. We're gonna do it.
Okay, somebody have answers?
Yeah.
I have the equation. Are you guys feeling confident? Are you good? Okay, so then what is the total ionic equation? Working. Thanks for the email. So you're starting to stress?
Cause I have your exam after this, I haven't finished the practice yet, I'm like 10 months spring, finishing that. And how's that working, homework to do?
I did tell you guys I'd seen their home, right?
Yeah?
Yeah, their homework for a couple of days to the weekend.
Oh, that's it. I'm still worried about it, like. Failed.
They give you guys that number 10.
Yes. Yes. Yeah, look, you guys copied it.
What do you guys have?
No.
Yes.
Sorry.
I see. I mean, yeah, I was doing it cheap. Just curious pages. Yeah, no, I got it. Okay, got one. That- So, everything else makes sense, just, you know, yeah, that's what sort of. Get it. When I'm supposed to be, don't call you.
It was like.
He just is so tired. He just looks at it. Even just. This give me some maybe the past few days. You get sick that they eat some sodium, that's what it is. What's up? There's chemical, there's a chemical food that cuts you asleep. Huh? Go ahead.
No.
I swear you, I was looking at you like, no. It's okay, I am sometimes. Just not to you though. What?
We heard that.
Unless because we heard.
You heard me?
Yeah.
Oh, am I that loud?
I heard you way back here.
Fuck, dude. Okay, we got some answers. How you guys feeling? You guys agree?
Yeah, I'm struggling a bit, but I understand.
Okay, what about you guys in the back, since you guys are the ones that? Okay, good. So. I'm gonna go, give me 15 more minutes and then I'll let you guys take a break, 15-minute break, and then we'll come back and do a lab. The lab that we're gonna do, I know you guys have to finish.
I think we all.
That's everyone.
All of you guys have to finish 9,
Yeah.
okay. We all have to finish 9? Okay, so we're gonna finish 9. That's our goal. Today, we're definitely gonna finish 9. If we have enough time, we're gonna do 10. We're gonna skip 8. I'm gonna give you the answers to 8, okay?
Yes.
Yes, I'm gonna give you the answers to 8, okay? Then I want us to do 10. 10 is important. 8 is just kind of like a little more redundancy, you know? So, and especially since you guys have already gone over the material, so it doesn't feel as much genuine. The stuff that you guys are doing today is gonna be valuable for 10. So, okay. Plus, you guys realize we got this much time to do this much stuff, right? It's happening fast. Stressing me out a little bit.
Yeah, we're just gonna do it.
Right on. Yeah, you can speak here.
For that big?
Yeah.
Yeah, right, no, that's you.
No, I have one right now.
Okay. Okay, so if somebody asks me, how do you know that that's gonna be a solid? How do you know? How do you know? Well, first off, when we're starting to do these reactions, you take a look at these reactions. I like to call these guys swinger reactions, right? I'll tell you why in a minute. You guys know what a swinger is?
Yes.
I'm not gonna ask. So, the reason why I call it a swinger reaction is because what happens with our conventional reaction is we switch partners. Sodium is going to hook up with the nitrate, and hydroxide is going to hook up with the manganese. Okay? So in other words, you're switching partners. It's also, its official name is called either a double replacement or a double displacement reaction, right? Because you're displacing one for the other. Okay. Now, usually when you do a double displacement reaction or a swingers reaction, you're going to get a precipitate, right? So, usually, right? And that's usually based upon characteristics of that chemical coming together. Now, the way that we determine whether something is going to precipitate deals with solubility. If you guys do me a favor, look in your packet here. I think it's 8. Page 8. Let me count. I'm old. Four. No, so 9, 10, 11, 12. Page 12. Oh, yeah, there we go. That's it. Looks like this.
Oh, okay.
Okay. Oh. Okay, so this table is like a little cheat sheet, or you have the option of memorizing one or the other, right? So if you guys do me a favor, you look up, let's look up barium carbonate. Barium carbonate. So barium, slide over to carbonate. What does it say?
Nearly insoluble.
Okay, nearly insoluble basically means it forms a precipitate. Anything that's in that orange color, or I don't know what color you guys see it. It looks like peach. Peach.
Yeah.
Okay, peach sounds good to me. Anything in peach basically means that under normal conditions, it's going to be insoluble, meaning that it's going to come together and form a precipitate. Right? Soluble basically means that you're able to dissolve it in water. So if we take a look at ammonium, look at ammonium. All the way across ammonium, everything is soluble. Everything is green, right? You guys see that? Okay. So since everything is green, that means that ammonium is basically dissolvable in water, regardless of who it's with, right? So regardless of who it's with, it's always going to be dissolvable in water. So it's always going to have that aqueous symbol next to it. Okay. So if I have iron hydroxide, iron 2 hydroxide. Nearly insoluble. What does that mean? It forms a solid. If I have copper nitrate, soluble. So you'll notice that almost everything with nitrate is soluble. Okay, so here's the other thing. Group 1 metals. Group 1 metals are which metals? Give me an example of group 1 metals. The alkali metals. All alkali metals, those guys are always going to be soluble. It doesn't matter who they're with, they're going to be soluble. Okay. Group 2 metals, it depends on who they're with, right?
Yeah.
Okay. For the most part, they're going to be soluble, but it really just depends on who they're with. Okay. So, and that's kind of clear on barium, right? You guys can see barium, soluble, soluble, insoluble, soluble, soluble, insoluble, soluble, soluble, right? If you go across, look at barium, barium is in group 2, right?
Yeah.
Okay. So the reason why, if you guys take a look at potassium on the next page. With everything, right? Because it's a group 1 metal.
Yeah.
So does that make sense? Okay, lithium. Lithium is soluble with everything except for phosphate. That's the only one that's an exception, right? Okay, sodium, soluble with everything. Okay. So that's how you know. Always half the battle.
Dr. Henry, does that have to deal with any specific measurement for them to be soluble, like for density or anything like that?
No, it actually, it deals with some of the characteristics of that particular atom, right? How big is it? Who is it interacting with? Do they have a strong electronegativity, right? Those are characteristics that determine that, right? And so it's kind of like the character of that element when they're interacting. So that's the factors that taken into consideration. Okay, so solubility is what's going to determine whether something is going to be a precipitant, it's going to be insoluble, or it's going to be soluble, right? Low solubility, right? It's basically going to form a precipitant, right? But it's low solubility. If it's high solubility, that basically means that you put in water, it just, hey, I'm good to go, right? So, okay, so here's the rules, or you can use that table. Solubility. So these are soluble components. Group 1 metals, always soluble. The ammonium ion, always soluble. Halides are always soluble except when they're with silver. Mercury 1 ion. Did I tell you guys about the mercury 1 ion?
You said it was a special case.
I did tell you it was a special case. Okay, so the mercury 1 ion. I'll actually write it. So mercury 1 ion is the only ion that is diatomic. Oops. So it's going to be written as Hg 2 plus. That is the only diatomic ion. Okay, so anytime that you see mercury 1, the first thing that pops in your mind, diatomic. Okay, now mercury 2 isn't a diatomic. So if it's Hg 2 plus, that's not going to be a diatomic. Okay, only mercury 1. Okay, so halides, when they're with mercury 1, they're insoluble. Okay, do you guys know what halides are? What are the halogens? Okay, so let's say if I have oxygen, right? When it becomes an ion, what is it called? It's called oxide, right? So if I have halide, what do you think I'm talking about?
Ions specifically?
I'm talking about specifically ions. Which ions?
Halogens?
The halogens, right? So when the halogens form ions, we call them halides. Okay. So halides are fluorine or fluorine ion, Okay, so group 17, thank you. Yes. Group 17. Okay. So lead 2, it's insoluble. Okay. Acetates are going to be soluble, bicarbonates are going to be soluble, nitrates are going to be soluble, and chlorates are going to be soluble. Sulfates are going to be soluble except for when they're with silver, barium, calcium, lead 1. I mean, not lead 1, mercury 1, lead 2, and strontium. And then you also know about manganese now. Yes. You have insoluble. So it's going to be insoluble when it's with carbonates. Now, don't mistake carbonate with bicarbonate. Bicarbonate is hydrogen carbonate. You guys know what hydrogen carbonate looks like? Hydrogen and carbonate.
Oh, I know, yeah.
CO minus. So that is the same thing as bicarbonate. So sodium bicarbonate, what is sodium bicarbonate? I heard somebody say it. Somebody say baking soda?
Yeah.
Yes, it's baking soda. Yes. So, and we know that that's soluble. We put it in water, what happens? Brush your teeth. Do your eyes. What was that?
Makes your teeth whiter.
Makes your teeth whiter, yeah. Okay. So, and then hydroxides are insoluble except for when they're with group 1 metals and they're with barium hydroxide. Okay. Questions? So what is easier? Is it easier to remember the table or use the table, or to remember that? The table, isn't the table nice?
Yeah, the table pretty nice and tells you.
Okay, so, and then eventually what happens is that you start remembering things like, hey, yeah, shit, I know this, you know, okay? Okay, so we're gonna stop here.